Hello everyone. Today I'll be going over the behind the scenes of the image processing project. This is going to be going over the technical side very quickly since it's more about the coding part of things. If you're curious, you can look at the code linked in the description below. And the more that I'm going to be focused on is the actual post-processing process. How am I going to actually manipulate the images, right? So let's get on with it. When it comes to the technical side of things, there are a couple of things we have to consider. How we're going to display the image, how we're going to save the image, and how we can manipulate the image, right? Because this is going to be what the code is like. I press run. This is the image that is going to be popped up. This is a random image with a random post-processing step that I've just had somewhere. And if I press S, which I'm not going to do it right now, I'm going to do it in the demo later, it's going to save the image. So how is it done, right? So in actuality, what is going to be done is actually just basically creating a rectangle on the screen. So the program that I'm using, it's the library called OpenGL within C++. It basically works with a lot of triangles, right? So in our case, we're just going to draw two triangles. This is one of them, right? And this is the other one. The two triangles are going to be joined together to create a rectangle. Usually this is called a quad, and then I just pasted it on the screen, and that's it. That rectangle can have something they call a texture being put onto it. And in our case, we're just going to be using an image, right? So we can just paste the texture of an image onto the quad, put it on the screen, and that's for us to display. When we are saving, we could just simply do the same steps, but for a different display size, which is the original image size that we're going to be using. We paste a quad on, we paste a texture on, and then we save it. How are we going to save it, right? So in OpenGL, there's actually a function that's already made here in order to basically, um, where is it again? All right. Um, Here, read buffer, right? It's basically going to read the actual image that is pasted on the screen right now into an array, which is basically a storage of data. We pass on that storage of data to another library that is already made for us that's going to be writing that data into a PNG file. Then that's it. We get a PNG file. If you might have noticed, I actually haven't talked to anything about how we're going to manipulate the images, which is actually where using OpenGL actually comes in use for us, which is something they call shaders. Shaders are basically programmed code that acts on a lot of data at once. In our case, we can have it act on a lot of pixels at once, right? When it comes to OpenGL, there are two shaders, the vertex shader, which we are not going to use since it's really more about how we're going to deal with the actual fragment itself, how we're going to determine what the fragment is like. In 3D programming, this is where you would do something like calculating the normal of the face, calculating the position in relative to the world itself, something like that. In our case, we're not going to really use it. We're going to be simply using it to just say to the program, okay, where in the rectangle it is, right? In this rectangle, sorry, this one, where it is, and then which pixel of the original texture we're going to use, right? So for example, if it's a shader that is acting on this pixel, right? It's going to say, hey, go to this pixel right here, take the data from it, put it on the image. And then this information of where it is in the world is going to be passed on along to the fragment shader, where the actual reading of the texture is done. And the thing is, we can interject between between its process of being pasted onto the screen and actually manipulating some stuff with it. This is where we can do something like color correction, where we can do a lot of stuff with it, which is the purpose of this whole entire project, right? So, with that being said, let's get on to looking at some fragment shaders. So, which is actually like most of the process that's being done. While it does take a while to actually set all this up, it takes like 3 weeks, and then I'm never going to have to touch it again. But what we're going to be using is a lot of shader files. So for this, I'm going to be copying a simple fragment shader that I've done before because there's a lot of functions, and I'll go over them. But I'm going to be copying them, making another file out of it, right? So in this case, I'll just be copying this one. Oh, sorry. Copy. Actually, it's probably easier if I just make a new item called demo.fs. fs is called fragment, is standing for fragment shader. It actually does not matter uh, what extension to the file you're adding, since it's not really something that the computer actually cares about. I made a file. I'm going to be going into another file. I'm just going to be copying everything here. It did take me a while to actually write everything first, but once it's done, I just copy it and then use it again, right? Okay, so what is going to be done here? We're going to be dealing with a lot of the color values in here. So, for example, like, okay, what is going to be the float value, blah, blah, blah. What matters is the main function, which is going to be the main running function, right? I'm going to delete all of these for now, and there we go. If we press run, it will take a while to load, but ooh, actually, my bad. I forgot to change the file. I forgot to change the shader file into the file that we're using, which is going to be in here, right? Okay, we're using demo.fs. So let's try that again. Right, we're just going to have the original image that we have being pasted on the screen right here. So how's this done, right? The fragment shader file, we have the in here it says frag color equal texture one text quad RGB. Text quad is going to be the information that is going to be passed on from the vertex shader of where it is in the coordinates on the texture, right? And we say, okay, get the color of that texture, and then I'm not going to explain this yet. Say that the fragment color, which is the color of that pixel, is going to be equal to that color that we've created, and then that's it. That's what we're having. But what is this OKLab call thing, right? So basically, this is something we actually not like to call. This is something that we call the color space. Basically, if you think about colors in computers, most of the time you think about RGB colors. However, that's actually not the best color that you usually use, because when it comes to RGB colors, it's not really that accurate. And it's really annoying to actually deal with stuff like the luminance of the color, the hue, the contrast, and a lot of stuff. Instead, usually people convert it to another color space before going ahead and then doing some stuff with it, right? In this case, I'm using a color space called OKLab, which is actually being created by just a random person online. And here it is. It's a perceptual color space, as he said, and it's going to be used a lot. And it's actually one of the most commonly, not most commonly used, but a lot of widely accepted as probably one of the best so far. But this field is always developing. There's always people researching different color spaces, and it's really a really exciting field actually. Back to the topic. Basically, we have the OKLab color, which in this case, instead of it being RGB, is going to be an LAB value. And as it says here, L is a perceived lightness, and AB is going to be more of the hue of the color, how green and red, and how blue and yellow the color is, right? So in that case, what if we do something like, let's say, let's take the OKLab call that we have. We um, the thing is .r the OpenGL program doesn't really know that it's going to be LLB now. It only have the context of RGB as its value, as its three of its decimal values. So instead, we're going to be multiply. Let's try multiplying it by 1.5. Let's see how it happens, right? We press run. We see that the image is much brighter. And the thing is, when it comes to brightness, it's going from 0 to 1, right? How are we going to deal with this? So what about if I do something like here? Let's say 1.0 subtracted by the lightness value that we have, and then multiplying over 1.5. It's going to invert the lightness of the color, right? Because if it's bright, it's going to be one near closer to 1. If it's dark, it's closer to 0. If you take 1 minus that value, it's going to inverse. The bright parts will become dark and the dark parts become bright, interestingly enough. And, well, if you've noticed so far, this is a lot of math. And that is exactly the case. Post-processing, if we are doing it simply by code, it's just basically getting some values, messing around with it, see what happens with it, right? And for example, what if we have something like red value, right? This is just the red value that I've gotten online randomly, and I am basically going to, let's say, okay, let's shift the color of the cracks from white, or in this case, it's a little bit yellowish, right, onwards to red. So we could do something like, okay, let's make it look like a graph, right? So what if it's like, let me just delete this first. What if it's like, let's say, okay, this is how bright it is, right? If it's more bright, then it's more red, for example. And then we could do it like this, right? Thing is, there's already a function for it, and it's called mix in OpenGL. And in actuality, it's called linear interpolation, but and it depends on whatever library you're using. If you're using DirectX, it's called LERP, linear interpolation. And in OpenGL, they prefer to use the word mix. And the thing is, I never remember how it's actually ordered, so Google. That's the thing with computer science. We Google every single time we are actually doing something. So it seems to be that mix is going to be going from X to Y with an A value. So basically, it's going, if we read it, it says, okay, this is the start, right? So this is going to be where X is, um, and this is going to be where Y is. And then A is like, A is going to be, okay, so how far we're going to go in this line. So what if we do something like, let's say, okay, lab call dot A, which is because we are going to only deal with the hue of the color, right? And let's say, let's have it mix between the value of the black color, which in the original one, I have to like, okay, what is going to be a good color for it, blah, 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 mix around a lot, and then it's going to be involve a lot of trial and error, right? But basically, okay, back to this. Let's say we go from, where's the code again? All right, we go from, uh, I did convert into the OK lab color space with lab black and lab red here, by the way. So yeah, there we go. Lab black. Actually, I forgot it's not LAB, it's RGB. It's always confusing. And it's lab red.g and OK lab call.r. This is basically going to create a linear interpolation from black to red for the value of A in here, and it's going to be determined how close it is between black and red in by the brightness of the color at that point, for example. This is just basically just messing around with colors, and I'm going to do the same thing with the B value. For some reason, B is the same letter. We go from that, we go, and then we convert it back to frac color, and then we paste it. Let's see how it goes. And it did not work. Something's wrong, right? The thing is, we never know what's actually going to happen, so we just have to do some trial and errors, see what happens, right? And this is going to be a very, very long process usually. You don't really know what happens, right? So instead, just for the sake of saving time, I'm just going to be going back to what I actually did here, which is actually not using this at all. Funnily enough, I just simply changed the color back to change the color to just change the color to red. Okay. I think it's like if it's black, it's probably not going to be affected by anything at all. Yeah, so this is going to be what happens, right? Because we changed the color to red. And then what else did I did here? I did a lot of math here. This is a lot of just trial and error. Okay, what function can I put in here? Let's see what happens because I have no clue what happened. I did some quantization here, which is basically like instead of having it be a smooth step, it's sort of like a step down, almost like pixelated. Here, actually, let me just Google up quantization. Image processing. Is there any image of it? No, not really. Ah, sort of. Okay, so instead of it being smooth colors, it's just going to be almost pixelated, right? Since doing that is actually going to help it look better sometimes. Will it look better? You have no clue. Just gotta try it out, right? And then if when I finally do it, it's going to look something like this. Am I content with it? Let's say I'm content with it. If I recall correctly, this is actually like, yeah, I did some things in here, like multiplying it by how far it is from the center to have it look darker around the corners and then have it look brighter around the center, like this. And it looks quite nice. Let's say I'm content with it. What am I going to do? I'm going to press S, and it will be really annoying if I'm actually dragging the window and it's not moving. It says it's not responding, but it's actually being saved because it's take quite a while to actually save, and it's going to freeze the program a little bit. Jankiness of code. It's going to take a while. But basically, once it's being saved, it's going. I said that I'm going to save. I said in the code here. Actually, let me just show you. I said in the code here to just save it in image result, and with this name, I could change the name if I want. I just save it to the same name just for convenience sake. I check image result, and it's going to be in here. Yeah, yeah, and it says save. That's just what I type for it to say, and that's it. That's about it when it comes to actually like doing stuff. And due to some bug that I do not know what it is, when I save it actually like completely zooms into the image, and it's some weird stuff. I would have to look more into it to know actually what happens inside, but for our purpose, it's good enough. That's about it actually for my uh project when it comes to actually processing some stuff. When it comes to how long I actually do to process some stuff, just messing around with the numbers, it takes me like about an hour or two to do an image for this one. Or sometimes it actually takes almost nothing at all. Because, for example, here I will actually show you one thing, right? I have this moon image. Right. I'm not going to change what is going to be saved as because I'm not going to save it. And then I have this shader I named Moonburst. So for this one, right, for this one, I actually had no clue what it's going to look like. If you don't believe me that I have no clue, I literally just say, oh, multiply it by 10 million. Who knows? Who knows what will happen? Turns out it looks pretty cool. And if you notice, sometimes if you actually do some stuff with the post processing, we have some artifact of noise, which is even it might be caused by the noise inside the camera, or it might be caused by the noise inside the post processing itself. We have no way of knowing. It could be some artifacts of the actual calculation itself. But in the end, we have some cool images and we save it. And some fun stuff is that we could even use the same fragment shader for other images as well. Let me see. Okay, I named it mushrooms. Right. For example, this one. It's pretty much the same fragment shader. I apply it to an image of mushrooms where originally it looks like it's not loading, but yeah, you get the point. It looks like just a normal mushroom image, and then I put it here. It looks really psychedelic, like you're on shrooms, and it looks really nice. So I'll just go along with it. Yeah, let's work with it. And yeah, that is basically what I did for this project. I hope you enjoyed the behind the scenes. And I know this is a lot of technical stuff, and but I hope you gain some knowledge from it. I hope you gain an appreciation of what goes on in actually processing the image and what goes on behind the code, behind the scenes of your favorite image post processing. Is it better than my code? It's definitely better than my code. It's probably a lot more well thought out than what I have here with something like sliders and a lot of stuff like, okay, how are we going to do luminance, how are we going to add some more effects to it. But this is a very basic form of it, a very primitive form of it, I would say. It is, and that is basically it. Thank you for watching.